Okay, multiplying fractions. This is section 8.3. Okay, 8.3. And we're going to be multiplying rational polynomials. Actually multiplying and dividing today. Okay. All right. Is this thing working?
I think so, yes.
Okay. So, let's take couple of problems here. I hope you like factoring.
Oh, yeah.
James,
I like
you like factoring?
I love it.
Good. Take a look at the first problem here. Okay. And this is really not multiplying fractions. All we're doing here is simplifying it. We are reducing it. One thing you cannot do is cross off the b squares. This does not equal negative 49 over negative 8b plus 7. And you cannot reduce the 47 and or the 49 and the 7. You can't do it. You can only reduce if things are factored. So let's factor the top. So we have b minus 7b plus 7. The more you factor, the better you get at it. On the bottom, it's an easy factor, b minus 7 and b minus 1. Now that they're factored, I can see that the b minus 7 on top and bottom can cancel each other out. And I'm left with b plus 7 over b minus 1. And let's start. Okay. Second equation. Now in the second equation, I could multiply across the top, multiply across the bottom, and then reduce it when you get to the end. That's pretty tough. Okay. So let's cross-reduce or try and reduce up and down and maybe simplify that a little bit. I'm going to rewrite the problem. 28 over 4a cubed times 4a to the 5th over 21 times 3 over 49a to the 4th. Okay. What does it look like to you that I can reduce?
3 and 21.
3 and 21. Good. So we'll make that a 1. And I don't need the 1 up there, but if you want to put it up there, you can. And that makes that a 7. Now, for the 7, I could reduce the 7 with the 28. Or I could reduce 28 and 49 by dividing by what goes into 28 and 49? 7. I could do that too. Either one.
Can you do both or
No. Can't do both. So let's do the 28 and 49. I don't know why. All right, let's not. All right. We'll do this. Okay?
Is that 7 turn to 1?
Please do not take don't take any shortcuts here. I'll explain what I mean in a minute. Yes, Mike?
Does that 7 turn into a 1?
It does. Because we're actually dividing. 7 into 7 goes 1, 7 into 28 goes 4. All right. And it looks like those two 4s can cancel out too, doesn't it?
Yeah.
All right, so let's do that. And what I'm going to do, and this is my way because I don't like making mistakes, I'm not going to just cross off the 4. I'm going to cross off the whole thing and make this a cubed. And cross off this because I'm just taking off 4s. All right, and that's an x to the 5th up there. It didn't look good, but it's x to the 5th.
Could you take off all of that and just make that like?
I'm not taking off all of anything. What I'm doing is specifically. Okay? All right, now, let's say, how about the a to the 5th? What does that reduce with? A to the 3rd? Okay. I could reduce it with a to the 3rd or a to the 4th over here. All right, let's do this. And what do I have up here? What's left up here? A squared. Good. Can I reduce that a squared? With what? A to the 4th. That gives me the 1 up here. And the a to the 4th, that gives me a squared. Can I reduce anything else? I don't think so. So now I can multiply across the top. 4 times 1 times 1 gives me 4. On the bottom, 1 times 1 times 49a squared, and I'm done. What I don't want to see happen is this. Okay, you're going to get goofed up if you try to take those types of shortcuts. You can reduce the a to the 4th and the a to the 5th, but it becomes a to the 1st, and I believe you should set that up on top. All right. Don't try and take these little shortcuts. I know some of you will, because you're going to miss something along the way, because it does get a little involved. Yeah, yeah.
So if it's just an A or just an X, you can change it to a 1.
If you have a to the 5th over a to the 4th, it's a to the 1st. It's just a. It's not a 1. But if you have a over a, that's 1. The a's will cancel out. We've done that before. Yeah. Okay. Let's take a look at the next one. Now look, if you try to multiply across the top, multiply across the bottom, and then try and reduce that, it's almost impossible. Our factoring skills are not that good. And it might not even be possible, okay, with the tools that we have. So let's factor the numerator, x minus 5, x plus 5. Factor the denominator, x minus 3, x minus 2. Like I say, the more you do, the better you get. Times, we have the difference of two squares, x minus 2, x plus 2. And factor the denominator, x plus 5, and x minus 3. Everything's factored. Now that it's factored, now I can start crossing things out. I can start reducing. So x plus 5 will cancel with x plus 5. I have x minus 2 and x minus 2. And I believe that's it.
X minus 3.
No? Got to be top and bottom. Can't be across. Now I can multiply across the top and across the bottom. Across the top, x minus 5 times x plus 2. Across the bottom, x minus 3 times x minus 3. Now you're going to see that I assigned the odd problems so that you can check answers in the back. I'm okay with leaving this problem in factored form. The back of the book is going to give you this answer, x squared minus 3x minus 10 over x squared minus 6x plus 9. It's going to actually multiply that out. If you're checking answers in the back of the book, that's the answer in the back of the book. But I don't care if you leave your answer this way. Just understand that they're both the same. Okay? First problem we did, just reduce fractions. The second problem, we did some multiplication and we did some cross-reducing. You could cross-reduce. You can reduce up and down. Okay, can't reduce side to side. And the third one, we factored first and then did our reducing. Division. Here's an example of a problem. Can I reduce anything? No, not yet. Because the only time I can reduce is when I'm multiplying fractions. Anybody remember the rules for dividing fractions? No, you don't cross multiply.
No, you multiply the reciprocal.
You multiply by the reciprocal of the divisor. That is a definition of division. The definition of division says when you're dividing, we multiply by the reciprocal of the divisor. And the way you learned it probably is you flip the second one and multiply. So 18 over 25. Now I can cross reduce. There's no cross multiplying. 5 and 25, 18 and 27, well 9 goes into both. Now I can multiply across the top, 1 times 2 is 2. Multiply across the bottom, 3 times 5 is 15. And that's how we divide fractions. We have to, it's an extra step. We flip the divisor and multiply by the reciprocal of the divisor. So let's take a look at this equation I have up here. X plus 3 quantity squared. Emily, I'm going to write that as x plus 3 times x plus 3. Is that okay with you? All right. On the bottom, I'm going to leave that as x minus 5. I'm going to turn the division into a multiplication problem. I'm going to take the x squared minus 8x plus 15 and put it on top. I'm going to factor it while I do that to make it x minus 5, x minus 3. And then I'll take the x squared minus 9, put it on the bottom, and I'll make that x minus 3, x plus 3. And now I can reduce. The x minus 5 and the x minus 5 reduce. The x minus 3 and the x minus 3 reduce. The x plus 3 and the x plus 3 reduce. What am I left with? I'm done. The second problem is really another form of division. And what this says is, and I'm going to rewrite it, x plus 2 squared over x minus 3, I'll put that in parentheses, divided by x squared minus 4 over x minus 3 quantity squared. Because really that's what this first problem says, the top divided by the bottom. I decided to rewrite it. I don't know why. I do know why. The more steps I take, the less mistakes I make. So the first one, x plus 2 times x plus 2 over the x minus 3. And now I'll flip the second one, right? And as I do that, I'm going to make that x minus 3 times x minus 3. And then I'll factor x squared minus 4 into x minus 2, x plus 2. Now that everything's factored, now I can look to reduce things. X minus 3, x minus 3. X plus 2, x plus 2. I'm done. I can't reduce any more. So it is simply x plus 2 times x minus 3 over x minus 2. It does not reduce in any way. Again, in the back of the book, they're going to multiply out that numerator. It's going to be x squared minus x minus 6 over x minus 2. That's the answer they will give you in your book. You can leave it in factored form if you like. You're going to see problems like the third one. How do we handle that? How do we handle that?
The right side first.
Do the right side first. Very good, Dale. Do the right side first. So let's take x plus 1 over x minus 1 divided by x over x plus 1. Let's do that first. So I have x plus 1 over x minus 1 times x plus 1 over x. Wow, does anything reduce? No. So now I've got x plus 1 times x plus 1 over x times x minus 1. I couldn't reduce anything. Now we'll take this that says x over x squared minus 1 divided by what I got when I did the second one first. And don't we have to flip and multiply? Okay. So I have x over x minus 1, x plus 1 times x times x minus 1 over x plus 1, x plus 1. Looks like the x minus 1s and x minus 1s will cancel. Gosh, does anything else cancel out? No. You tried to trick me here, I think. So x times x is x squared. And I have x plus 1 times x plus 1 times x plus 1. I'm just going to write x plus 1 cubed. Okay. All right, so far? Hang in there. We got one more. First of all, you cannot take those x's with negative exponents and start moving them up and down. Can't do it. Can't flip them. Cannot do it. Here's the way you have to handle it. Let's rewrite. 1 plus. Now you got 12x to the negative 1. We have to write that as 12 over x to the first. Only the x goes in denominator. Plus 27 over, now we'll make that x squared, over 1 over x plus 9 over x squared. So the first thing I did was to get rid of the negative exponents. Now, does anybody remember how to simplify these complex fractions? How can I get rid of those complex fractions? Anybody remember? I think we did that back in chapter 2, I think. Maybe 3. Do what? No, we can't do anything there. Yes. We're going to multiply something by numerator and denominator. And I'm going to multiply by, isn't x squared over x squared 1? So I'm multiplying by 1. Let's distribute. X squared times 1, x squared. X squared times 12 over x gives me, this x will cancel with one of the x's, and it will become 12x. And what happens when I multiply x squared times 27 over x squared? I get 27. Okay, so we got rid of those fractions on top. And we do the same at the bottom. 1 over x times x squared gives me x plus what? 9. Yes. Much simpler problem now. I factor the top, x plus 9, x plus 3, over the x plus 9. My answer? X plus 3. Your homework. On page 502 and 503. 9 through 43, the odd problem. And 45 and 46, the odds and even. 45 and 46.